Good evening, parents and students. Hope you're doing well. In our math, we've been looking at multiplication comparisons, and everyone's been doing very well with that. Very proud of everyone out there. We're going to take one step into adding one more thing to our multiplication comparisons, and that's adding an unknown. So if you remember Mr. Budinger's 3-number principles, we have two numbers and we're usually looking for one, and up until now we've been using a blank to indicate that's something that needs to be filled in, usually a number. Well, now we're going to start putting a letter in place of that blank. So we're going to be looking for two numbers, and then the letter is going to represent the number that we're looking for. And I'm going to show you how to do that in math. This is relatively complicated. It's not an easy concept to pick up right off the bat, but it is an important one, and one that we're going to be using in the future. So go ahead and work through this worksheet. There's a sample, two samples along with it, and try and see if you can complete the remaining of the worksheet using unknowns in place of blanks. Give it a good shot. For week 24, we're going to look at multiplication comparisons, and a lot of you have really got a strong understanding of multiplication comparisons. We're going to add one more thing, and that is what's called unknowns. Sometimes it's called unknowns, sometimes it's called variables. But using letters as unknowns, n, in place of a blank, here's the blank, when following Mr. Budinger's 3-number principle. So usually there's a blank space at the end of an equation or a word problem, and you're supposed to put the number in at the top of this blank space. We're going to use a letter which is called an unknown in place of that blank. So let me show you how that's going to work. Let's use this first one as an example. Now, if you remember from multiplication comparisons, we'll go ahead and read through this equation part, and then we'll get to the model part. 54 is 6 times greater than n. Make an equation using n as the unknown. Okay, so if you remember from our previous worksheets, is kind of the new equal sign, and 6 times kind of goes together when you ever see times next to a number. And then this is going to be the unknown. So instead of a blank space, we're going to put an unknown there. So let's go ahead and write out the equation. 54 is 6 times greater. Now, sometimes we have as many as. Okay, so we're using a little bit different words here. We're going to use those interchangeably just for you to get a good idea of how this might look. 54 is 6 times, oh, I guess I should have an S on that. 6 times greater than n. 6 times greater than n. So here we're following the order again, and this is what the equation looks like. Now, we aren't solving for n just yet. We're just going to leave this as equation. Okay? So let's put a little comma here. The next part, it says make an equation, model the equation and find the value of n. So we're just going to follow the order of how it's laid out here in our short math statement. So let's go ahead and make a model of a multiplication comparison. And for the last few weeks, we've been using this ribbon model. And we've been trying to discover where we should put these numbers. Now we're going to use an n in place of a number. We aren't going to solve for n just yet. So how do you think this ribbon model would look? Well, if we follow the same order of this equation, we could say, well, 54 is going to be the product, and I know that the product goes down here. That's going to be the largest amount. So it has to take into consideration this whole amount. And 6 times, just using a little bit of memory, we can say, well, the 6 times goes on the top, right? And then this has to be divided into six equal parts, and whatever number n is would go in those parts. So let me show you how to do 6 equal parts. We're going to divide this into thirds first. Okay, I try to divide it into thirds as equally as I can. Now I'm going to divide these thirds, this one little third section, I'm going to divide in half. And I'm trying to be as careful as I can to make all these boxes look the same size. This one looks a little bit smaller, but I did my best, so we're just going to leave it at that. Now I have my Mr. Budinger's 3-number principle here. One of them is an unknown letter now instead of a blank space. So watch what I do with that when I'm looking at my model here. I put n in place of that number. Did you see that? So I have my 54 here, I have my 6 times up here, and then that third number, even though I may want, or my instinct is to put a number in here so it makes sense, we're just going to put this n. Are you still with me so far? Okay. So now the last part is find the value of n. So what would the value of n be to make this, to solve this equation? Sometimes we say solve this equation. Sometimes we say to make this model true, or to make both these this equation and this model true. Remember, both these have to agree with each other, and so far they do. But now we have a value n that we have to consider, and there's no blank spaces here anymore. So this is how we, if n's unknown, this is how we solve it. We say n is equal to what number here would make both these true. If you said 9, you're correct. So if I put 9 in here, I'm saying 54 is equal to 6 times 9. And if you know your skip counting, you're going to say, oh yeah, that makes sense. Over here, you're going to say if I had 6 9s, that's 9 6 times, I'm going to have 54 of whatever happens to be our units. We're just using numbers right now. We aren't talking about units just yet. So this would be 9, 18, 27, 35, no, wait, well, I got that wrong, I think. No, I'm skip counting. I'm trying to skip count by 9s. 9, 18, 27, 36, 45, 54. So yes, that would work out too. So this 9 makes this true, or solves this model as well. And over here I'm just saying this is what I'm replacing 9 with. It was an unknown. I didn't know what that number is, but now that number is going to be 9. And we don't have to go back and put 9 in here anymore. This is complete. So look at these other ones. It's a little bit complicated to get your mind around, using 2 equal signs, like we use an equal sign over here for the equation, then we're using an equal sign over here for n. That's a little confusing. Writing n in different places, and you could have an n down here with 2 numbers, or you can have an n up here with these 2 numbers given. Try and get an idea of like where this n might go. But at the end, we always have to solve whatever n should be to make these two, both the equation and the model, true, or equal to each other, or I shouldn't say equal, equivalent to each other, because these are 2 different things. Let's look at a word problem down here. How would we do that for a word problem? Now down here it says make a 3-column T-chart. I'm going to do that first. I'm not going to read the word problem, because every time you see a word problem, you should be making a 3-column T-chart. And I'm just going to fill in everything here. Every time you see a word problem, you should have this 3-column T-chart already filled out, without even reading the word problem if you don't want to. Okay, now let's go ahead and read the word problem. If your friend has 32 tickets and you had 8, how many times more tickets, here's that, how many times more tickets, T, would your friend have than you? Use T as the unknown. So we're going to use this T in place of tickets. So if we look in the question, we try and fill out what's known here. We have 32. We have 8. And instead of putting a blank here, what do you think we should put here? What letter is going to be the unknown? If you said T, you're correct. Okay, let's look at our question. How many times more tickets T would your friend have than you? So the units is going to be tickets. And the operation, we're doing multiplication comparison, so you know that we're going to be using multiplication for that. Now, how would we model that? Well, we know that we're going to use a ribbon model. We have these three numbers. Which one of these do you think is going to be the product, the largest of the number? If you said 32, you're going to be correct. And how many times more? Times come over here. How many times more tickets T? Here's that times word again, but we don't have any number for that. So we're going to use our unknown T up here as T times, and then we have our 8. So you can see how difficult this becomes. We don't know what our T is just yet, or how many times we're going to divide this this ribbon model into boxes. Let's go to our equation. 32 up. It doesn't look like I'm starting with a 3. 32 is, you had 8, something times. So we're going to say T, okay, because that is what we don't know is how many times. T times 8. Okay, we have everything filled in that we know. If you look over at your equation over here, what value of T would make this statement true? Some number times 8 is going to give us 32. If you said 4, you're correct. So T is equal to 4. Over here, T is equal to 4. So that means we have to divide this ribbon model into how many equal boxes? 4 equal boxes, because T is equal to 4. You know how to have T4 here, T4 here, and T4 here? I'm not putting the value in here for T. I'm saying this is what T is going to be. This is the unknown we were looking for. And where does 8 go? 8 would go in here. Now, there wasn't any room for statements down here. We'll tackle that later on. I know that that's kind of missing here. But I just want you to get the idea of having an unknown in place of a blank and how that might work. This is kind of difficult work. So stick with it. Try and get as many answers that you can explain correct. Okay, I want you to be able to explain how you came to your answer. Give it a shot.